So in today's session, you will be learning what is data modeling and what is relationship and what is cardinality, how to define or create a relationship between the tables. Okay, previously you learned how to connect to different or diverse data sets using Power BI. Now we will see what exactly data model and why we need it, and then let's see how to create the relationship between the tables. Okay. So to start with, let us understanding what exactly data model is all about. What is data model? What is data model? Data model is something like a roadmap or blueprint. Before you construct a house, you see the blueprint, isn't it? Without seeing the blueprint, if you blindly close your eyes and if you start construct the house, what will happen? Later point in time, if you want to make even a small changes to your house, it involves too much of rework, correct? For example, this is what you are, one second. Yeah, you have a blueprint readily available. So what you can do is uh, you can take a look at the blueprint and then decide whether the blueprint is up to the mark or is it meeting your requirement or not. Okay. For example, you need 3 bedrooms and 1 living room and 1 kitchen, right? And you need to have for each bedroom, you want to have an attached bathroom, right? So you need all the thing, and also in your kitchen, you need to have the the water tap, 2 water taps. You want it, something like that. Okay. So in that case, what you do is when you look at that, you will come up with more questions. So does this does this house, the new flat or house, provides all the provisions or not, right? One second, I don't know why it's hanging. So what you do is before starting the construction, in case of any alterations that are required to your house, you can tell the architect to make changes to the blueprint itself. It's all in the paper only. Okay, making changes to the paper will not take much time. Rather than breaking the house and changing the the provisions, everything, it involves to cost cost wise prohibitively very high, right? You cannot afford, and especially if you live in an apartment. So you need to get permission from all your neighbors. Okay. In that case, you will end up having tough time to change the provisions or to put some to include some new features or additional features that is not possible in some cases, or it requires a lot of approval from your neighbors and association, everything, all the confusions are there. So that's the reason why. So what we do is we'll just look at the blueprint. So here let's this is my 1 bedroom, and here my kitchen is there, and here I have another bedroom. This is your entrance, something like that, right? So you here you have puja room, and you have another bedroom here. So 3 bedroom, and this is your living room. This is your dining or something like that. Okay, this is your kitchen, and here you need to tap. So that you want to have the bore water as well as the metro water, everything. Okay. So when you see this, you are quite happy, right? So sometimes you might want to change this plan and you want to tell them, hey, instead of keeping the puja room here, why don't you keep the puja room here? Okay, so that my dining hall will be, spacious, and also in the living room, if anyone comes, right, they will have the sufficient space to sit here and, do something like that. Okay. So before constructing the house, you have the blueprint. And if you want to make any changes to the blueprint, you can tell the architect and they will make it and they will suggest the feasibility, okay, whether it is possible or not, okay. And then they say, okay, we will make some changes to that. Okay. So just assume that you don't have a blueprint. What will happen? You construct the house. It's a 18-floor house. It's it's apartment. What will happen? In the apartment, you live in one flat. right? In the 18 floor building, one flat you have an house, something like this. After constructing the house, if you want to change the rooms or here design everything, it's a problem, right? And importantly, the taps. So here you have the, you have the restroom. Here we have another restroom, and the toilet should have proper, the taps, right? Number of taps should be there. The appropriate number of taps should be there, right? All the things should be there, okay? But without having the blueprint, if they construct the house, later point in time, let's say you realize in your flat, let's say you live in sixth floor, and you need some additional provision. You want to keep, additional taps here, or you want to have some concealed pipe, okay, to keep the cable connection, all the things, right? In your bedroom, you want to have additional concealed cables and cables, and also in your living room, also you want additional. So all these things before construction, if you come up with a plan during the time of construction, they would have taken care of everything. But without the blueprint, let's say you are living a sixth floor and you want to keep some concealed pipe or something like that to keep, the cable TV connections in all the three bedrooms and plus in your living room or even the broadband connection. It's a painful task. Again, you need to go and get the permission from your neighbors and apartment association, everything, and you need to break the wall, everything, right, from others' wall also, and then you need to bring the provision here. This is a painful process. Before, likewise, right, before you construct any applications, for example, you want to develop a website or mobile app, you develop any kind of app, you need to have a solid data model in place. Without data model, if you start developing or building the application, it is somewhat similar to building a house without having the blueprint. Later point in time, if the customer comes back and says, hey, I need this specific report, I need this specific requirement. So in that case, if your data model is not flexible or robust, you end up making changes to your data model. Sometimes what will happen is, it is something like you redo everything from the scratch. Just to make few changes, you have to redo everything there. For example, you don't want to have the bedroom here. Instead, you want to have the kitchen here, you want to have the bedroom here. After constructing the house, again, you need to break it everything. In Chennai, one issue happened, right? So because of Vastu issue, he was breaking something and whole building got collapsed. Okay, whole building got, because of this guy, the whole building got collapsed. Similarly, when it comes to the application development or something, even if sometimes what some tables to accommodate as part of your existing tables, you may end up recreating everything from the scratch. Okay, so that right, make sure that you have a solid data model design in place and understand the requirements holistically from all the stakeholders, all the department stakeholders or people in your company, and then start design the data model. Okay, so data model is somewhat similar to roadmap or an architect's blueprint. So in the data model, it involves defining the relationship between the tables and so on. Okay, fine. Next one is 1 second. Sorry, there's some issue happening. 1 second. I think because of the two thing, it's causing problem. Okay, now I think I'll be all right. No, still it is causing problem. 1 second. Yeah. So why do I need to have a data model? That is what I discussed a while back. Without a solid data model design in place, later point in time, if you realize you need a couple of tables, new tables that needs to be, or additional tables that needs to be included as part of model, it involves complete rework. Okay. And so for example, let's say you are designing the data model for a grocery store. Okay, grocery store. You are designing a data model for your data grocery store. So in that case, what are the entities that are involved in the case of grocery store? Customers, right? If you have a grocery store, obviously the customer is one of the important entity. The customers will come and buy the products from your shop. So they raise the orders. Customers raise the orders. Each order will have at least one or more products in it. And each product may fall in different categories, right? So these are the important tables that are required before you develop any application or something like that. So when you have a discussion with the stakeholders or the application owners, while having a discussion with them, you will get to know what are the entities are there, how these entities are interacting with each other, what is the data flow, everything. You will be able to understand as part of something called conceptual data model. There are three types of data model. One is the conceptual data model and the logical data model and physical data model. The conceptual data model, it gives us it helps us to understand the high level entities. So in a grocery store, like I said, what are the entities? Or entities are nothing but tables. What products, and product is a table, right? It's a table. We need to have a separate table called product to hold all the products, and sales to capture all the transactions. We need to have a table by the name of sales, and store. What is store? Store is nothing but the grocery store itself. Okay. And then, you have a product and you need to have another table called category. Okay. And purchase, you have another table called purchase. Represent the transaction of customer buying, or in this case, sales, right? And this is the thing. And the relationship also, you understand at a high level. So a store has many customers. For example, you have another table called customers, right? A store has many customers, and a store sells many products. A product belongs to a category. A single customer may purchase more than one product, or they make many purchases. A sale includes many products. Okay, so these are the relationship exists between the tables. A store has many customers, right? And it's not each grocery store, not only one person is visiting, right? So let's say if you are grocery Reliance, let's say your Reliance store is there, and just in front of your house, it's a grocery store. And every day customers, different customers, they go and buy it. The store has many customers, and also they sell more products, many products. Okay. And each product, belongs to a different category. Okay? A customer makes many purchases. These are the relationship between the tables. Okay. As part of conceptual data model, you understand what are the entities are there at a high level and their relationship within a grocery store. Okay. Next one is the logical data model. So as part of the logical data model, what we do is we go one step further, and then we define, we add additional details. Here, okay, time, product, sales, store, and we have another table called customer. Okay. So in that case, each table, what are the columns that are required? For example, you have the store table, store ID, and store name, and store address, store phone, and other details. Okay, created when this store got created. All this information. Similarly, you have customer table, customer ID, first name, last name, email, phone, all the information. And you have the product table, product ID, product name, description, price, and category ID, and so on. Okay. Similarly, you have a category table, separate table, additional table, category, wherein you define the category ID and category name. So the these tables, the conceptual data models, right? This is the one we come up initially when we conduct a workshop or when we initiate a discussion with each department or line of business stakeholders, right, as part of that, we get to know at a high level what entities are required, how it interacts with each other, okay, and what relationship exists between those tables, right? That will help you to understand high level. Just having a high level information is not sufficient. You need to go one step further. Okay, you need to evolve your conceptual data model by adding the columns that are available as part of each and every table. Make sure that you are including all the necessary columns, as part of the each tables. Okay, this is very much important. And next step is the physical data model. Physical data model, what we do is we go one more step further, and then along with the column name, we define the data type. Okay, which column needs what data type. So this is the product description is obviously a text data type. In SQL Server, we call the text data type as a varchar, and 50 is the width of the product name. Okay, you can increase the width or something like that. Okay, if the product name is too big, you can increase it. Okay, you can specify not only that, the data type, and also you specify the, width of each column. How much text needs to be, accommodated in each column, right? All the things, you define it here, okay? So like I said, right, a store can have multiple customers. So in that case, one-to-many relation. So I just draw it here, 1 second. So let's say you have something like customers. So in addition to that, you have one more table called customer. So a single store can have multiple customers, okay, one-to-many. So you will find something like crow's feet. So one-to-many, and this is nothing but crow's feet. You know crow, right? Crow. Okay, crow's feet. It is called crow's feet. The crow's feet is something like this, right? Hence they call, so whichever tables, whichever table you find the crow's feet next to it, that means that's a many table. Okay, a single store have many customers, and also a store sells many products. A store sells many product. Okay, a store sells many product, and a product belongs to single category. Let's say we have another table called category. Okay, each product may fall in different categories. A sale includes multiple products. A sale includes multiple products. Look here, next to the product, we can see this grows with. That means, right, multiple products are there here. Multiple, many. This is many side, and yeah, these are the thing. Okay, and each product can appear multiple time here, right? So multiple time here. Okay, each product can appear multiple invoices, right? So for example, product A. Let's say you bought a earring. Earring is appearing multiple time. Or let's say you bought a broccoli vegetable. Like you, many customers they purchased broccoli. Hence, broccoli can appear multiple time, right? So here, zero or sorry, here multiple products can be purchased by the customers, or multiple products can appear in the transaction table, and each product can appear multiple table in this multiple time in this table also. Okay, and here zero or many products you can find. That means, right, so not necessarily, let's say you have let's say 100 million, let's say 100 million products you sell it, like Amazon or someone, right? So in that case, what will happen is not necessarily this week all the customers would have purchased all the products which you sell it, right? Not necessarily they have to buy all the products that you sell it. Some product they did not buy it. So hence zero or many. So zero or many. Okay. So zero or many products can appear in fact sales table, and each transaction can have multiple products also in a single invoice, right? Let's say you go to a shop and you buy multiple products. You go and buy the vegetables, for example, broccoli, onion, tomato, multiple products, you buy it. Single order, multiple product. Okay, and there are products, right? It may not appear in your fact sales because certain products we did not sell it in this week. Okay, hence zero or many, and here many. Okay, in this case, yeah, almost all the each product can appear more than one time. here, and each invoice or each order can carry multiple products also. Okay, it may contain one or more products, but at least one product should be there in your sales table. Okay. So now you understood what is conceptual data model. It's in high level. In the when you have a discussion with the customers as part of your requirement phase, you understand what are the entities that are involved in that specific business and how how it related with each other. You will be understanding by having a discussion with them. Next step, what we do is just coming up with the big picture is not sufficient. Next step is you go and come up with, you go and add or include the number of columns that needs to be there in each table, and then you define the relationship, logical relationship. Okay, and finally what you do is, along with each column name, you specify the data type. So date ID is an integer data type, date description is a text data type, right? So all the things you define. Along with that, you specify the width also, with 30 or 20 or something like that. Okay. Hope you understood these three types of the data model. See here if you join any software company, right? We have something called SDLC life cycle, software development life cycle. Okay, as part of that, the first one is your requirement phase. The customer will explain their requirements, reporting requirements, right? You need to come up with the strategy to pull the data from the source systems, and as part of the requirements phase, for example, in India, let's say you work for Accenture, okay, in India office, and in USA, let's say USA you have Walmart, right? The Walmart, they have San Jose, they have Walmart, and what they do is, when they during the status call or during the discussion with the customer, they explain what are their requirements. First of all, they'll give you the document, okay, requirements document. You need to understand the requirements document by going through that document, and also have a discussion with customers. So what to understand the requirements clearly, and also in case of any gap in the requirements, right? You can go and explain the customers, what gaps and how you can address all the things during that call. So that time, as per the requirements phase, you come up with the conceptual data model. Okay. So what tables are required, how many number of tables are required, and what relations, how each tables interact with each other. Next one is the design phase. Once the requirements, so as per what requirements document, either they will give you or they just give you the high level requirement after having a discussion with the US customers, right? And then let's say you work for Accenture, you are the business analyst. What they do is, they come up with a detailed requirement document. As part of that, they will include this model also. And finally, after creating the detailed requirement document here at Accenture team, right, the business analyst, they will share it with the US customer, Walmart, and they will review the design, everything. In case of any gap, they will say, hey, you need to change this one, you need to change this one, or include additional tables. Like, for example, here the category table is include that. And then customer table is missing, please include that. So they will tell, once you include everything, you need to, in your document, right? So you need to share it with them again. And finally, they sign off. They will do the sign off. Only they approve it. Next, it will come to your design stage. In the design stage, you come up with the design document, everything. Okay, what is the volume of each table? How many number of records that needs to be loaded? And what are the source systems, tables that we need to access it in order to get the product related details? What are the product they sell it? From where I can get it? And the sales stance, in which table should I hit it and get it? And store, what are the stores? How many retail stores they have it? And what are the locations, where can I get the data, right? So you go and find out the appropriate data, everything you will document, design document, how the detailed data flow between the tables, everything. You will be, they will be, storing, they will be, they will be documenting in the design document. And next phase is your coding phase. Coding, and next one is the unit testing. So up to this, this is the one most of the developer's job. Let's say you are joining as a developer, Power BI developer or data analyst. If you are a senior data analyst, you will be involving in design phase also. Okay, design, coding, unit testing, and then the QA. It is the QA team, the testing team. They will test your report and ETL jobs, everything, and finally it will go to the user acceptance testing. The customers, right? They will test the reports developed by you. If they find any gap or if they need any additional requirement, they will get back to you. And then what it is, you need to fix everything. And finally, everything goes well, it goes to production. This is what called as a go live. We need to understand all the terms because interview time, they might tend to, use these terms, then and there. Okay, and don't panic if they say what is go live, right? So don't get panic. So go live is something like production. If everything goes well, for usually this is the process. Okay, so you develop the reports and ETL jobs, and then as a developer, it is your responsibility to come with a test case and test it whether the report created by me is meeting the reporting requirements of the customers. You need to test it. Okay, and everything, and then if you while testing it, you might find some bugs in your code. You need to fix it, and finally you need to get back to the QA team, the quality team. Okay, so they are the one will test your report. If they find any bugs, they will raise it in a defect tracker. Okay, and then it is your responsibility, right? As a developer, you need to go and check the defects raised by the QA team and fix it if it is really valid bug. In case of the bug raised by them was not valid or applicable, you can go back and tell them, hey, this is not the bug. Okay, this is the requirement from the customer or something like that. Okay, you can justify them, and if they are fine, they will move to the UAT environment. This is another database where the users will start do the testing on the reports developed by you. And if they find it any issues, they will say no. Again, they will raise some bugs. Okay, you need to fix it. Or if everything goes well, okay, what they do is they say, go ahead and deploy it in production environment. That is what your go live. Okay. So this one, the conceptual data modeling, you come up as part of your requirements phase. And then the logical data model and physical data model as part of the design phase itself, you'll be doing it. Okay, you'll be completing as part of design. Which one? The logical data modeling and the physical data modeling, you do it as part of the design stage itself. And again, right, you need to share the document with the customer. Each phase, these are called phases: requirement phase, design phase, coding. Each phase, you need to share the document with the customers and get their approval. And then only you need to move to the next stage. Okay. So the next stage, here you do coding and the unit testing as a developer, and QA and everything, you do it. That's all. Okay. This is how it works. So the conceptual data model comes under requirements phase, and physical and logical model falls under your design phase. Got it? Okay, fine. So next one is the why do I need to have a data model, first of all? So, okay, fine. Understanding the number of tables, how many number of tables are required, and what are relation, how the each tables are related, fine. So how it is going to be helpful? So when it comes to Power BI, it is the responsibility of the developer, Power BI developer, data analyst to develop the data model also. If you are lucky, let's say in your project, you have a dedicated data architect. In that case, they are the one responsible for coming up with the data model design, everything. Okay. But most of the projects, right, you need to do the data model design. Now the question is, why should I do the data model design? This is specific to Power BI again. In Tableau and ClickSense, you don't have to do the data model design. Okay, it's all taken care automatically by those tools. But when it comes to Power BI, you need to, sorry, you need to explicitly, design the data model. Okay. So first of all, why do I need to have a data model design? As I told you, this is specific to Power BI desktop. You need to do the data model design explicitly. Though Power BI can do the data model design automatically, it detects the relationship between the tables. Still, you need to do some kind of tweaking. Let's wait for a few seconds. This takes some time. The newer version is far slower than the older one. But the design is really good. The latest version of the Power BI desktop. Here I'm going to select the new. 1 second. Yeah. So I'm going to click on the get data. I'm going to load some table. Come on, what is happening here? It is very slow here. I'll just close this one. And here, what I'll do is I'll just use the same tables. Dim location dimension. I'm going to hit open. It's still being loaded. Let's wait for a few seconds. Unfortunately, it takes longer time than usual. Let me just kill this one. Yeah. So this is the location. I'm going to select the sheet one. On the right side, you will find all things. Yes, obviously this needs some, the data transformation. I just clicked on the Power Query Editor. I'm going to promote the first row as a column header, okay? Because the columns names were not correct. I click on the transform ribbon. Wait for some time. It's too bad, Microsoft. I don't know why it takes this much of time. Okay, let me click on the transform ribbon, and here you will find use first row as headers. As usual, I'm going to click on this first one, the first option. So the location key and location name got moved here. And now what I do is, in the interest of time, I'm going to load another file from here itself. The sales fact table. I just load it. This sheet, NC sales, as usual. I'm going to hit OK now. Okay, everything looks fine. I just rename this one with the meaningful name, sales fact, and this one is your um, dim location. So all the location related details along with the location name is available in location dimension table. And then the sales fact table, all the transactions, right, are available here. Okay, including the location key and customer ID, product ID, all the things are available here. So I'm going to apply the close and apply this. Now I'm going to close this one. I don't need this any longer, the Power Query Editor. Wait for some time. Oh, wait this much of time. I closed many files. Oh, still it is going on. Let's wait for a few more seconds. Okay, and I'm not sure why it takes a lot of time. Man, it's real killer. I'll just close this. Let's wait for a few seconds. So until this one get closed, right? It'll be like that. Let me check, are there any root process running in my laptop? It will not take this much of time. Control Alt Delete. There is some issue. Yeah, memory and CPU 100%. Something consumed too much of CPU. Maybe this is the guy is causing problem. I'm using this annotation thing. Maybe because of that, it takes. Hmm. Now it got reduced. Performance, I can see that. Yeah, there's too much of CPU was utilized due to some problem. I don't know. Let me just close the PowerPoint also. Maybe because of that. CPU 22%. Yeah, now the CPU is falling down. It is overutilized, the CPU. And the memory, okay, memory is also too much. I don't know why it took this much. Otherwise, I will better restarting. Restarting take attention required. You must restart. This virus, antivirus software is another pain. 1 second, I'll just check it here. Power BI, Power BI. Microsoft Power BI. Where is that main? Okay, it's killing my time. Power BI. Yeah, this is the one consuming too much memory. I'm going to end the toss better. Better will start the new one. And I'm going to open new one. Get data. I'll just redo the same thing. Sorry guys, it's taking time. Usually it will not take this much time. You need to select this one and I just load it. What I'll do is I'll just save it quickly. NC sales, I just rename it as sales fact for the sake of clarity. We are done. So the next, I just click on the model view. The model view, we can see that the sales fact table, okay, all the columns, everything, okay, all the things, you can see it here also. And the next one is I just load the uh, location dimension table, the Excel file, okay. So basically, you want to create a report wherein you want to show the total sales made, or you want to see the sales breakdown by location, sales breakdown by location. And here, the sheet one is nothing but your location dimension. I quickly click on the transform, and here I just say promote the headers, and I just rename it as dim location. Close and apply. Cool. I just click on the model view. So we can see that the location dimension table and the sales fact table got linked with this line. Can you all see this line? That is, this line is nothing but the relationship. Next to this location dimension, you can find the one here. Next to the sales fact, you can see the star here. So that means these two tables have one-to-many relationship. One-to-many relationship. That means each location can appear multiple time here, more than one time. Each single location can appear more than one time in this fact table, invoice table. Okay, Chennai, Bangalore, Chennai. Last week sales. Let's this data set contains last week sales data, and not only Chennai, all the locations data you will have it here. Okay, and when you link these two tables, you will get to know the breakdown of sales by location. Okay, how much we sold in each location, which location tops the sales, all the things you can see it here. So the relationship between these two tables got created automatically. Now what I do is I just hover the cursor on top of this line. The moment when I hover the cursor on top of the line, you can see on both the tables, the location key column got highlighted. Can you all see that? Location key column got highlighted in both the tables, isn't it? So when I move the cursor away from that, it is not showing that. So what it says is both the tables got linked based on the common column location key. If you don't have the common column exists between these two tables, you cannot create the relationship between the tables. For example, I just go to the report view. Okay, I'm going to click on the this chart, the clustered column chart. The moment when I click on it here, it will get dragged and dropped here automatically. I just resize it. Next one is I just expand the location dimension. I just drop the location in here. And then the sales fact table, I'm going to drop the sales amount in this table. The sales amount came from the sales fact table, whereas the location name came from the location dimension table. Got it? See here, the sales amount we dropped in this table. Location name also we dropped here. Okay. But these two columns came from two different tables. As I told you in the previous session, if you wanted to pull data from more than one table, you need to join those two tables based on the common column. As part of left join, right join, inner join, we discussed, right? Common column should exist between the tables in order to perform merge. Similarly, to create the if you are using multiple tables, you need to create the relationship between the tables. Okay. So here, the moment when I drop the location in and the sales amount from these two tables, right, it automatically gives me the breakdown of sales across the locations. I just increase the font size so that you can see it very clearly. Somewhere blank is there, let it be there. I just close this one. I'm going to close the filters. I think all of you can see it very clearly. So now what I do is if I hover the cursor here in Chennai 406, right? 4,06,000 and odd, and that is the sales. And Delhi 21,200, and Hyderabad 7,986, and Pune we have something like that. Okay, it gives us everything. It gives me what I did, I just dragged and dropped the location name column from here. That become a x-axis, and the sales amount, now it is getting displayed on the y-axis. You can drag and drop it directly, whichever columns that you need it, right? But one text column along with that, one numeric column should be there in most of the cases, okay, in your visual. Okay, the text column in our case is location name. The numeric column is our sales amount. You don't have to specify x-axis, y-axis, it automatically takes care of it. And if you, one second, if you go here, the visualization, if you click on the add data to your visual, and you can see the location name in the x-axis automatically, right? It appears here. And sum of sales amount. The moment when I drag and drop the sales amount column, it does the sum automatically. That is the reason why. What is the total sales in Chennai? What is the total sales in Delhi? We can see it here. Usually we aggregate the data, we summarize the data, and so that's why it shows. So now what I go to the data model view, I keep the cursor on top of this line here, right click on it, I'm going to delete it. Now, if I delete this, these two tables become standalone, independent. Okay, there is no relationship defined. So what will happen is if I go and see my report, all the cities, it shows the same total sales. See, 4,57,000, what you see here is all the city put together, what is the total sales? What happens, all the cities, it shows the same amount. It is not doing the filtering correctly because we don't have the relationship exists between these two tables. I dropped it intentionally to show you why you need a data model design in place. The data model is nothing but having the right set of tables in your report file. At the same time, the relationship to be created between the tables. Look here, how do I create the relationship between the table now? Keep the cursor on top of the location key. So in this table, I have only two columns, location name and location key. But here I don't have the location name, only location key is there. I want to create the relationship between the tables. In order to create the relationship between the two tables, both the tables should have the common key column here. What is the common key exist between the two tables? Location key, right? I just select the location key. I drag it and drop it exactly on top of the location key. You need to be very cautious here. Location key column, you need to drop it on top of the location key column only, not on the other column. It will cause confusion. To check whether the relationship got created correctly with the appropriate columns, hover the cursor on top of this line. You can see the location key from both the tables got highlighted. Now, if you go back and see here, look here, it is doing the filtering correctly. Now you understood why data modeling is required. One second, I just one second here. I'll just open the PowerPoint. So why data model is required? Now you understood. Without creating the data model, which means the relationship, if you don't define it between the tables, you will see, all the months, in this case, all the months have the same value, which is wrong. It is not showing the accurate values in your report file if you don't define the relationship between the tables. Here, this relationship automatically deducted by the Power BI desktop. How it deducted? It checked both that what are the common columns exist between the two tables. Since location key is available and also it is available here, it created the relationship automatically. Supposing here the location key name is slightly different, location space key. In that case, it will not create the relationship between the tables. how Power BI will get to know location space key is same as location key, right? So both the table column name should also be same, but in the real world scenario, the column names sometimes it will not be same. Okay, they say location ID or location key. Since you are part of the company for a longer time, you will be knowing. Okay, this is a location ID, location. Both of them are same. Now also when you double click on this line, it will open up something like this. Okay, it will open up a window, something like this. Here we can find the location key column got highlighted in a sales fact table. Location key column got highlighted in dimension location table. It tells you many to one relationship exists. The many side is sales fact table. One side is your location dimension table. Cross filter direction is single here. So the gray colored one or the common column exists. So by looking at these values in this column, you can make it, hey, this is BLR, CHN, and even if the column is different here, location ID, whereas your location key, it will not create the relationship automatically. You need to, you need to drag and drop it here. Location ID, you need to drag and drop it on top of this location key column. Fortunately, in both the tables, the common column name, location key, the naming convention properly follow. Okay, hence it automatically detects the relationship and it creates a relationship. But to demonstrate you without the relationship here, if I delete it, what is going to happen? It is not going to show the accurate data. Hence, I recreated the relationship between the two tables based on the location key. Now, I just show you one more time. I just delete the relationship between these two tables. And when I go back here, it will not show the correct breakdown of sales across location. If you want to see the breakdown of the sales across location, you need to link these two tables. So since the location key is common, I select this location key, I just drag it and drop it exactly on top of the location key. Don't drop it on some other column. Okay, location key column should get dropped on a location key column. And if I go back here, yes, it is doing the relation. So with this, we are able to understand with the data model only, right? We can do the slicing, dicing. Without data modeling, you cannot slice and dice your data. So what is slice and dicing? This is the common term used by the BI guys, business intelligence guys. Slicing is something like, you have the, let's say this is for your birthday, you bought a cake. Okay, you bought a cake and right, so you bought a cake and so you want to give the cake to those people attended your birthday party. You just slice this cake, right? You just cut it. So in our case, right, the same principle applicable here. So this, just assume that this is a data, right? The entire data is available. You don't need all the data. So in our case, we just wanted to see the location, right? You just, you just selected the location, all the data, you don't want to see that. Location specific, you want to, specific location also you can select. Within that location, if you wanted to do further analysis, right? That is called dicing. First, take this subset of the data and then you do the dicing. Dicing within that, you do all kind of analysis. That is what called as slicing and dicing. This is the term used in any data warehousing or analytics project. Remember this. So without creating the relationship between the tables or without having the data model design, you cannot slice and dice your data. Only when you slice and dice your data, you can analyze your data in multi-dimensional. Okay. Visual displaying the values appropriately over time. No, right? So here in this case, I have used month instead of the location name. Your month is a text. In the x-axis, we have used the text column and y-axis, the sales amount used. Since there are no relationship exists between the date and the sales table, it is not showing the correct results. Hence, remember this, guys, we need to have the relationship defined between the tables. Only when you define the relationship between the tables, the filtering is happening. This is the one you need to understand very clearly. Even experienced people, they got confused with the term filtering. Okay. For example, instead of location and sales table, for example, we have another two. Let's take these two tables for our illustration to understand what is filtering. Filtering, can happen only when you define the relationship between the tables. So in this case, let's this is your customer, country dimension table. This is country. This is the sales fact. You just think that sales fact. Okay. So in this case, for example, your manager wants to display in the report, specifically wants you to display the country name along with the quantity and then sales. Quantity and sales are available in which table? The quantity and sales are available in this table, right? But country name is available in this table. So to create this report, you need to read the data from two different tables. In order to read the data from two different tables and display the two tables data in a single report, you need to create the relationship between the tables based on the common column. What is the common column here? Country ID and country. None of the column, so other than the country ID, can you see any other common columns? Nothing, right? So here the country ID is called your primary key. Primary key. I'll explain what is primary key. So in the primary key column, you will find only the unique value. The US will not repeat more than one time. AU will not repeat more than one time. Unique values only allowed here in the case of primary key column. This is your dimension table. Hence, you will have a primary key. Along with that, the specific primary key's description, you will find it here. But here the country ID can occur more than one time because in US yesterday they purchased 2 quantity, and in today they purchased 6, and another customer purchased 5, another customer purchased 5 quantities for different products. Hence, this is a invoice table or the fact table. In that case, the same country ID can appear multiple times. Fine, everything is good. What exactly filtering is all about? So here, as I told you, if you wanted to, bring in two different tables, columns in your single report, you need to create the relationship between the two tables. The common column is country ID. You need to drag and drop the country ID and put it here. A link will get created. Here you will see one here. Here you will see star here. Like I have shown you a while back, right? This is a many side. This is a one side. So what happens is when you define the relationship link, okay, when you define a link, what will happen is it does the filtering. The country dimension table filters your sales fact table. How it filters? First, it goes to the first record. Okay, the first record, what is there? US, United States. The country ID is US, right? It sends the US country ID to this table, and then it filters only the country ID related data, US related data. So we have created the relationship based on the country ID column. So moment you create, filtering will happen. So this US country ID US will get propagated to this sales fact table. And what happens, wherever US is there, first it will get grouped. And then it applies sum on your quantity column. If you have used sum on your quantity column and sales, right? And then first it goes and checks, what is the total units we sold in US. So 10 plus 6, 16 plus 2, 18. So US is 18 quantity. Similarly, it does the, the sales, right? Total sales also it puts here. And next it will go to the second record in your dimension table. Australia is there in the second record. Next, what it does is it goes and it sends the AU ID to this table. Hey, group all the Australia related record. Now you do the sum on the quantity. And then you do the sum on the sales for the Australia only. So Australia is how much? So 2 plus 7, 15, 17 units. Similarly, it does the total sales for, this one also. This is called filtering, guys. So this filtering is happening automatically when you create the relationship between the two tables based on the common key column or, common key column. This is very much important. But once you define the relationship between the tables correctly, it does the filtering automatically. That is the beauty of Power BI. Got it? So next what will happen is once it does, here instead of Australia, it put the Australia. In your report, you need the full name, right? Australia and United States, right? Okay, something like that. So next one is it goes to the Germany, and then so Germany, the full name is Germany. In your report, you will get the country name correctly, Australia, United States, and then Germany records will get grouped. 20 plus 60 is 80 units sold, and similarly these values will get added. You understood? This is called filtering. Filtering is possible only when you create the relationship between the tables based on the common key column. Otherwise, the filtering will not happen. That is the reason why the moment when I dropped the relationship between these two tables, this one, right, it was not doing the filtering correctly. So now in this case, what happened? Each and every location will be sent here, propagated. They use a fancy term called propagated. That means the each and every location key will be sent here. That specific location key will, related records will get grouped here. For example, if I go here and if I select the sales fact, and what is your location? First record, let's say bank BLR, right? The BLR column will be sent here. The value will be sent here. And then it applies this filter automatically in the behind the scene, okay? All the BLR record will get grouped and it does the, sum on quantity. It does the sum on sales amount automatically. Once it does the total sales and total quantity for Bangalore, next automatically it goes to the next city. And here it does the same thing. It does the total on the quantity and sales amount so that for each and every city, you will get the one-liner. In Bangalore, tell me how much quantity we sold in total. And in Chennai, how much sales we made. And, likewise, we can see there also. Okay, you can drop the quantity also here. So this is your quantity here, right? So total quantity, all the things you can see it here. Okay, so the smaller one is the quantity, the bigger one is the sales. Okay. So in Chennai, how many units we sold? You can see that 2,309. What are these? The sales for 2,309 products, 4,06,000. Similarly, that's the grouping for each and everything. Okay, this is called filtering with the relationship created between the tables. It does the filtering automatically. Otherwise, it will not do the filtering. Next one is, okay, that we will see later. And 1 second. Next, we will jump into understanding what is relationship. So we have seen, yeah, relationship is nothing but filtering. Relationship is nothing but filtering when it comes to Power BI. Remember this. I explained you what is filtering, how it happens. Okay, and here, these are the different types of relationships are there in general. This is not specific to Power BI. You take any analytics project, in the case of data warehouse, right? They define the coordinator like something like one-to-one, one-to-many, many-to-one, many-to-many relationship. Okay, so cardinality is nothing but relationship. In the interview, they will confuse you with the different terms. Don't get swamped. Okay, the cardinality is nothing but relationship. Relationship nothing but cardinality. If somebody says no, what is cardinal? Tell them it is a filters or it is a relationship. Why do you need to create the relationship between the tables? By defining the relationship between the tables, it can do the filtering automatically. Otherwise, it will not do the filtering automatically. Okay. What are the different types of coordinator relationships are there? One-to-one, one-to-many, many-to-one, and many-to-many relationship. What is one-to-one? Give me an example for, one-to-one relationship. One-to-one relationship. One-to-one, the simple example is the Aadhaar card and the individual. For example, this is Aadhaar number. Aadhaar number and a person, right? Each person should have an Aadhaar number, and each Aadhaar number will be used for a single citizen. Okay, the same Aadhaar number will not be used for more than one person, and each person should have only one Aadhaar number. That's all. Okay, so this is an example for one-to-one. And next one is one-to-many. So what is one-to-many relation? Give me an example. The interview, they'll ask you, What is one to many? One to many is, this is the one. An employee is, a single employee is working on multiple projects. It happens in the software industry, right? Or even in the manufacturing also, single employee is working on multiple projects. For example, this is a retail, your project name is Retail Sales Analytics. Okay. Your name is Raja. You are, working in Retail Sales Analytics project. And at the same time, you are working in other project also, Supply Chain Analytics. Supply Chain Analytics. Single person may be working in multiple projects. That is called your one-to-many. Another example is a student, right? A single student, right? So he may be attending different courses. So he may be attending data analytics training, and other one is, he is attending IELTS, training. Students, right? Students can attend more than one courses. Phone number linked to many accounts, right? One to many. Yeah, we can say that one also. The best example is, yeah, the account number, right? Yeah, single account number in a bank, a single account number can be related to more than one person, right? This is person one, person two. Why? Is it possible? Can a single account number can be assigned to more than one person? Can more than one? Is it possible? Bank staffs can tell me. Is it possible to assign a single account number to more than one customer? Yes. Joint account, right? Joint account. The single account is associated with multiple accounts. Okay, this is an example for one-to-many. Yeah, correct. PAN number, correct. PAN number, a single PAN number can be assigned with the multiple thing, okay? And similar other examples, like a car manufacturer produces many car models. For Mahindra, they produces multiple Thor, right? The Thor vehicle, they produce it, and then they have XUV models, right? XUV is different. A single manufacturer produces multiple models. A single customer can order more than one item. These are the examples for one-to-many relationship. What is many-to-one relationship? The opposite. Okay. Multiple employees are working in a project. Multiple. For example, HDFC Bank, multiple employees are working in a single bank, right? That is an example for many-to-one relationship. Or in the case of software project, multiple employees are working in a project. So more than one employee can work in a project. Even in the case of construction, to build a single house, multiple, daily wages are working, right? So this is called many-to-one relationship. More items ordered in a single order. This is another example. So now the question is, yes, now I understood what is one-to-one relationship, one-to-many relationship, many-to-one relationship with examples. Next, we'll see how we can create the relationship or data model design in Power Pivot. So it is also called as the Power Pivot, which in the model view is also called as a Power Pivot. So now what I do is I just go ahead and load some more tables. I click on the Excel workbook, and here I'm going to say category. I just click on the category. I just load it here. So I just select this first one, and yeah, I just click on the transform. It requires a little bit cleaning because the column names were not displayed correctly. We need to promote the first row as a column here, and here I just go and use first row as headers. So category ID and the category name. And now what I do is I just go ahead and close and apply. Let's see what happens. Yeah, the table name was not, the naming convention was not followed correctly. This is the one is related to what? DIM category. But in this case, what happened? there is no relationship exists between these two tables, right? Sorry, oh my God, I gave the wrong name. This is sales fact. Mistakenly, I gave the wrong name for. Okay, here it is a dim. But if you see here, only these two tables, have the relationship, but this table has no relationship, right? We have to create the relationship. Unfortunately, Power BI desktop could not create the relationship, between this table, because category ID column and category column is that this category ID or category column is not available in any of the tables. Can you see category ID here? Nothing, right? Your category is also not there. Category ID is also not there. Hence, it remains standalone. Now, let us see what happens. I'm going to load another table, dim product. And this is the one dim product. Yeah, I just hit load. But the moment when I loaded the dim product table, it created a relationship between these tables, right? How many of you noticed this one? Automatically it detected a relationship. Now I just hover the cursor here. You can see on the both the tables, both the dim product as well as the sales fact table, the product ID column got highlighted. Next to the product dimension table, you can see one here. Next to the sales fact table, you can see the many here. So the sales fact table got linked with two tables, dim location, dim product. But this table remains standalone, right? It is not linked with any other table. So now what I do is I just move this down to the fact table. All the dimension table, I keep it on top here so that we can visualize it correctly. And the category table remains, the standalone here. But here, what I do is I know very well the cat ID in this table and then the category ID in this tables holds the same value, holds the same value. I just show you the data here. For example, dim category, the category ID is there, and then the sales fact table. And here, sorry, the product table. Okay, in the product dimension table, you see the cat ID. Here, C0001 is there. The same thing you can see C001. But there is a category dimension table. There's a product dimension. In this case, I'm going to link, drag and drop the cat ID on the category ID column. I told you only when Power BI desktop can find the same column name between the tables, it creates the link automatically. For example, in this case, product ID, right? In both the table here, product ID is there, here also product ID is there. The naming convention is same. Hence, it created the relationship automatically. It was able to detect the relationship automatically. Unfortunately, here the category ID in cat ID, the naming convention is wrong. They gave the different name, but both the columns holds the same category name. That we know that by visually looking at the data in the product dimension table and category dimension table. I just drag the cat ID and then I dropped on top of the category. If I hover the cursor here, see, I just click on it here. When I hover the cursor on top, cat ID from dim product table and dim category table, you can see category ID. These two columns got highlighted, which means, right, these two columns, these two tables, common column is category ID. Sometimes the column names may not be defined correctly. As a data model, data analyst, you should be knowing what values are stored in which column, and by knowing which you can define the relationship correctly. But still, you need to verify with the customer. Okay. Also, you can rename it. Okay, here you can rename it. You just double click on it, and then you can expand the properties here. Here you can see the category ID also. Okay, but anyhow, I'm not going to modify it anything now. So now what you notice here, the difference, see the product location dimension table, product dimension table got linked directly with the sales fact table, whereas the category dimension table was not linked directly with the sales fact table like other dimension table. Instead, this table got linked with this table, and then this table got linked with this table. Not necessarily all the tables should link directly with the sales. Sometimes the dimension table, one dimension table may link with another dimension table, and that one will get. Supposing you want to filter, you want to use your category column category dimension to filter a sales fact table, you need to do it via this one. Hey, it's something like this, guys. For example, in your house, right, most of the house, right, you can see that the son will not talk to dad directly, right? Instead, he will talk to his mother. If he needs anything, he'll ask his mother, via his mother, he will, get whatever from his dad, right? It's something like this. Sometimes the relationship will be defined like this also. And what other tables are there? I just click on get data here. I'm going to load another file. Customer dimension table is there. I just load it here. I just click on this sheet 1 here. Here also it requires, because the custody first names are not available in here. Instead column 1, column 2, column 3, column 4 are available. The column names were not defined correctly here. Hence, I'm going to hit the transform data rather than load button. I'm going to hit the transform data button. I just rename this sheet 1 as bin customer. Here, the custody, first name, last name, gender, you can find it in the first row. Ideally, this one is supposed to appear here, but here it appears like this. Hence, what I do is I promote the first row as a column header. I select on the transform here. Click on the use first row as headers. I just select this one. Now, the first row got promoted as a column name here. Beautiful, right? I just go and click on the file ribbon and click on close and apply. Now I can see that, hey man, so even the customer dimension table got linked directly with automatically detected the relationship between the customer dimension table and the sales fact table. I just, keep it nicely here so that we can, all the dimension tables are on top here and the fact table is at the bottom. And if I hover the cursor here, in both the table, custody columns got highlighted. So with that, we can understand very clearly, since customer dimension table and sales fact table have the common column custody, it got linked automatically. So we have 4 dimension tables and 1 fact table. Of the 4 dimension table, 3 dimension tables got linked directly with your sales fact table, whereas the category dimension table got linked with the product dimension table. Now you can go to the report view and you can create whatever the report that you want. See here, earlier we had only the location breakdown, right? Sales breakdown by location. Now, if I click on this one, clustered column chart, now what I do is I can go to the customer dimension table. I just drop the first name here, one text column and one numeric column, the sales amount. Give me the sales breakdown by customer. So Chris is the one spent more in my shop. He's a potential customer. And Victor is the next, top spender in my shop, right? So it does the filtering automatically. So earlier we were having only 2 tables, the location dimension table and sales fact table. With that, we are able to, display only the sales breakdown by location. since we have included additional dimensions, now we are able to do the multi-dimensional analysis, right? The one so this is also called a dimension. Location name is a dimension, and the name of the customer is also a dimension, right? Multi-dimension we can do analysis. Similarly, we have product. When you drag and drop product here, each product, how much in total we sold, we can see that. Similarly, the category also you can find how much total sales we made in each category. I just click on the clustered column chart here. I just move this up, and here I go to the category dimension table. I drop the category here from the category dimension table, and I just drop the sales amount here. Instead of using this one, right, for all the visuals, for the change, I'm going to use the donut chart. I just clicked on the donut chart. Now it gives me the breakdown of sales by category. With that, you can quickly make out that under 5 category, this customer is selling their products. And each category, what is the total sales, and which category has highest market share. So the dairy, right? The dairy is the highest market share. Dairy is like your milk, curd, those yogurt, all the things falls under dairy products. So this company's major revenue comes from dairy product category. Okay, so here category with sales, you can see the breakdown, and here the location by sales breakdown, you can see that. Customer by sales breakdown, you can see that. These are all possible because you have include all the relevant dimension tables, but the category dimension is not directly linked with sales fact, but still it gives me the correct the result, because we have created the link between these two tables, and these two tables have a relationship. Not necessarily all the tables should have a direct relationship with your fact table, but there are some tables like this can have a relationship with other dimension table. So via this dimension table, category dimension can filter the sales fact table. That's all, guys. Is it clear? Hope you understood with this demo how to implement the data model design with this simple table, simple dimension tables, right?